Hi, my name is Cole Washella, and this is a presentation about the Mars Curiosity rover. Mission Overview. The Mars Curiosity rover departed on November 26, 2011, and arrived on Mars on August 6, 2012. The Curiosity rover carried the biggest and most advanced set of instruments for scientific studies that had ever been sent to the Martian surface. The rover was meant to analyze samples scooped from the soil and drilled from rocks, and it was to record the planet's climate and geology. The rover's onboard laboratory will study rocks, soils, and other local geologic settings in order to detect the chemical building blocks of life, and it will assess what the Martian environment was like in the past. The rover carries something that is called a radioisotopic power system, and it generates electricity from the heat of plutonium's radioactive decay. This gives the mission an operating lifespan on the Mars surface of a full Martian year, which is around 687 Earth days. It would also provide significantly greater mobility and operational flexibility. The Mars Curiosity rover arriving on Mars. The Mars Curiosity rover landed in the Gales crater. It used a series of complicated landing maneuvers that had never been before attempted, and a specialized landing sequence which employed a giant parachute, a jet-controlled descent vehicle, and a bungee-like apparatus called a sky crane, which was devised because testing landing techniques used during previous rover missions could not safely accommodate the much larger and heavier rover. Curiosity is about the size of a car, and it is designed to explore the Gale crater as well as other important parts of the Mars surface. Curiosity was launched from Cape Canaveral, and it landed on Aeolus Palus inside Gale crater on Mars. The Bradbury landing site was less than 2.4 kilometers from the center of the rover's touchdown target after a 560 million kilometer journey. As you can see by these pictures, it explains exactly what the landing technique was and how it was achieved. The goals of this mission. According to NASA, Curiosity had four main science goals in the support of the agency's Mars exploration program. The first goal was to determine whether life is on Mars or if there has ever been. The second goal is to characterize the climate of Mars. The third goal is to characterize the geology of Mars. And the fourth goal was to prepare for human exploration. These goals were divided into four other subgroups: biological, geological and geochemical, planetary process, and surface radiation. The biological goals were to determine the nature and inventory of the organic carbon compounds. It was also to investigate the chemical building blocks of life, which are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And the third part of the biology section is to identify features that may represent the effects of the biological processes. Moving on to geological and geochemical. To investigate the chemical, isotopic, and mineralogical composition of the Martian surface and near-surface geological materials, and also to interpret the processes that have formed and modified the rocks and soils on Mars. Moving on to planetary process. The first part of the planetary processing goal is to assess the long time scale, around 4 billion years, the Martian atmospheric evolution processes have occurred. The second part of the planetary process is to determine the present state, distribution, and cycling of water and carbon dioxide on Mars. Lastly is surface radiation, and that is to characterize the broad spectrum of surface radiation, including the galactic and cosmic radiation, solar proton events, and the secondary neutrons. The geology of Mars will help scientists better understand if the region near Curiosity's landing site was habitable by humans. And to assist better meeting these larger goals, NASA broke down the science goals like that into 8 smaller objectives. The characteristics and instruments of the Mars Curiosity rover. As you can see by this picture, the Mars Curiosity rover has an immense amount of instruments and important advanced technology. They have cameras that can take pictures of the landscapes or of minerals close up. The mass cam in the upper part of the Curiosity rover, the Mars hand lens imager, and the Mars descent imager are all used to take photographs of things close up. The Mars Curiosity rover also has spectrometers to better characterize the composition of the minerals that are found on the Martian surface. The alpha particle X-ray spectrometer, the chemistry and camera, the chemistry and mineralogy X-ray diffraction, and the sample analysis at Mars instrument. The Mars Curiosity rover also has radiation detectors to get a sense of how much radiation bathes on the surface, and this helps scientists understand if humans will be able to explore there safely, and also if microbes could survive there. The Mars Curiosity rover also has experimental sensors to look at the current weather and climate. Lastly, it has an atmospheric sensor that was primarily used during the landing, called the Mars Science Laboratory Entry, Descent, and Landing Instrument. The rover also has a few tools to search for habitability. Among them is an experiment that bombards the surface with neutrons, which would slow down if they encountered hydrogen atoms, one of the elements of water. Next is, what has the rover achieved so far on Mars, and what else may it achieve? The Curiosity rover has found many important findings already. It found that ancient Mars had the right chemistry to support living microbes. Curiosity found sulfur, nitrogen, oxygen, phosphorus, and carbon, and these are all key ingredients necessary for life. In the powder sample drilled from the sheepbed mudstone in Yellowknife Bay, the sample also reveals clay minerals and not too much salt, which suggests fresh water was possibly drinkable and then once flowed there. In the bottom right is the hole that they drilled in the Yellowknife Bay. Organic molecules are the building blocks of life, and these have also been discovered on Mars. After a long search by the Sample Analysis at Mars, the SAM, instruments in several samples drilled from Mount Sharp and the surrounding plains, this finding doesn't necessarily mean that past or present life is on Mars, but it shows that raw ingredients existed for life to get started there at one time. And it also means that ancient organic materials can be preserved for us to recognize and study today. These are my sources used for this presentation.